Now I do want to make some notes for this significant testing that we just carried out. So if your R is significant and your scatter plot shows a linear trend, then that line can be used to predict your Y values for X's that are inside your observed domain. So significant R, linear trend, then you can use it for prediction. Now if your R is not significant, or the scatter plot does not show linear trend, so you can have a significant p less than 0.05, but if your scatter plot, if the R value is something like 0.1 or 0.2 that shows little or no linear relationship, then don't use that line for prediction. You want to have at least a moderate linear relationship. So if your R is significant and your scatter plot shows a linear trend, though, that line might not be reliable if your prediction is outside your observed domain. So again, you need to stay inside the domain of the scatter plot. Now, when we did our hypothesis test for R, we had some assumptions that we made for that significance testing. First assumption is that the data are either a random sample or from a randomized experiment, so you need randomness. Also, you're assuming that there is a linear relationship in the population that's going to model that expected value of Y for any X. And then also the Y values for any particular X are normally distributed about the line. So here's a picture of that normally distributed. So here's a particular X value. And here's a picture of the points that have that X coordinate. And you can see that they kind of pile up more in the middle and less on the edges. So they actually look like this. They have a distribution, and it's a bell-shaped distribution. So, and that's for any X value. So we have another X value out here. Here's its distribution again. They pile up in the middle. It's a bell-shaped distribution. And the same for this X value over here. Here's that distribution. Lastly, the standard deviations of the population of Y values about your line are equal. So if you look at these normal distributions, you can see that the width of all of those normal distributions is equal. So the spread or the variation of these Y values for a particular X are all the same. And then your residual errors have to be mutually independent, which is saying that there's no pattern. So those are kind of some technical assumptions that we needed to carry out that hypothesis test. Most of the time you won't have to do any specific checking for these, at least not in this course.